Suppose we have 4 sets given. U is our usual universal set. It's the positive integers between 1 and 12. And then A, B, and C are 3 sets given. And what we have to compute is the result of A union B. And when this is done, take away C. So we have to subtract C from the union of A and B. If this is on a quiz or an exam, it is important for you to get partial points. And for that, you should have partial results. A union B is basically all the numbers between A and B. So that's 1, 2, whatever occurs either in A or in B or both is gonna go into the union. So we have 1, 2, 3, 4, 5. There is no 6, but then 7 and 8. No 9, no 10, no 11, but 12. So that's the union. And from that, we're gonna take away set C, which is 2, 3, 4, 6, 7, 11, 12. Now how that works is that we're gonna go through the elements of this first set, A union B, and the result is gonna be a subset of this because we're only gonna lose from here. And what are we gonna lose? Whatever is getting subtracted. So for example, 1 remains in our set because 1 is not getting subtracted via C, but 2 does. When we subtract C from A union B, we remove the number 2. And then we also remove number 4. 5 remains. 7 gets removed, but 8 remains. And 12 gets removed. So this is it, 1, 5, 8. So one useful comment here is that if we have a set S and we remove something from it, then the result must be a subset of S. Okay, the second question we have to solve is basically the same operations, just a little bit different order. The same operations, A union B subtract C, but now it's in different order. Now we're gonna take the union of A and whatever the result of B minus C is. So again, partial results are always helpful. A is easy, 1, 2, 3, 7, 8. And we take the union of A with the following set, B minus C. So what that means is that we're gonna have to go through the elements of B and whatever is also in C gets removed. So we start with 3, 3 gets removed because it's in C. Same with 4. Now 5 is not in C, so 5 doesn't get removed. 6, we don't even have to worry about it because it cannot be removed if it isn't there in the first place. 7 gets removed, 8 remains, and then 12 gets removed. So it's just 5, 8. So we take the union of these two sets. This here is our B minus C. So this means we just throw all these numbers into one set, whatever is in the first set or the second set or in both. So 1, 2, 3, then there is 5, 7, and 8. And that's the union. Okay. So if you're taking a quiz or an exam, I highly recommend that you do this because if you make an error, that error is going to be visible. And so you can get partial points. If you don't show work, you're forcing your teacher to give you a 0 as partial points. That's never good. That said, there is another way of solving these problems. So we can use Venn diagrams as usual to find the regions on the Venn diagram corresponding to this set. So A union B would be the shaded region, right? Everything only in A or only on B or both. And from that, we have to remove whatever is in C. So that means we would have to remove whatever is in this circle. But we cannot remove stuff from here because it's not in A or in B, but what we're really removing is this stuff here. And so after we remove C from A union B, we get this region. We can think about it one third way. It's related that anything in this set has to be in A or in B or in both, but not in C. Now for this other one, So we're gonna take the union of A, that's easy, and B minus C. What is B minus C? Well, here is B, and when we remove C, then we basically remove what we can, and that is the intersection of B and C. So B minus C would be everything that's in B, but not in C. And we take that, we take the union of that and A. And so the result is gonna be whatever we marked is good. Now the two results are not the same. What is the difference? I think the triple intersection is in there because it's in A. So the difference is these two regions are not in the first answer, but in the second. Obviously, the first answer is a subset of the second answer. So if we take the time to draw a correct Venn diagram and on this and perform these operations on these regions, then we can read the answer. However, my experience is that you should only do that if you're very certain in your skills. Some people are making the mistake when they come up with the Venn diagram. Let's see. 1 is in only in A, not in B and C. So 1 goes here. 2 is in A and C, but not in B. 3 is in all three, so it goes into the triple intersection. 4 is in B and in C. 5 is only in B. 6 is only in C. 7, it's in all three sets. 8 is in A and B, but not in C. 9 is nowhere to be seen, so it floats outside. Same story with 10, 11 is in C only, and 12 is in B and C only. So one way we check, if we read numbers in this bubble, we should recover all the elements of A. 1, 2, 3, 7, 8. That's good. B, 3, 4, 5, 7, 8, 12. Good. 2, 3, 4, 6, 7, 11, 12. And then we can do that with U. So every number should be listed exactly once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So very good. Given our solution for the first one, we have to copy the things that are in these three regions. This one, and this one, and this one. So that is our 185, which I'm going to organize as 158. And if we go back using algebraic methods, our solution was 158. The second one is those three regions and these two added to it. So it's 1, 2, 3, 5, 7, 8. So that one is everything that's in here. 1, 2, 3, 5, 7, 8. 1, 2, 3, 5, 7, and 8. The problem with this technique that it's a high risk that you're not going to get partial points if you make a mistake. And as you saw, it's very easy to make a mistake when we set up the Venn diagram. Thank you for watching.